Hi, I thought I'd share with you another augmented reality experience I've created, just another little proof of concept, this time combining 2D plane detection as well as gesture recognizers, which is sort of touching the screen on my phone and manipulating the objects in the augmented reality scene. So yeah, this is the scene behind me that we're going to talk about. And the experience we're going to talk about. And what I'm doing is detecting a 2D plane, i.e. my dining room table in this example, and it might detect others, but we're just interested in the dining room one. And then I'm touching that. I'm saying this is a surface I'm interested in, and it's going off and calling the Unsplash API, which returns some images, and placing that on the table. And then what I'm doing is I'm using UI gesture recognizers to move them around, rotate them and scale them a bit. So that's the code we're going to look at today. Okay, so this is the experience. Like I was saying, it goes detect the table. I've touched the table, it's put 10 images on there, and I'm just using the pan gesture on the screen to move them around. And see my finger there. Then I'm doing the pinch gesture to make it bigger, and then I'm doing a sort of like rotate gesture to rotate some of these, and it's quite a nice effect. And I'll show you the code how I've managed to do that. It's got quite a few applications, as you can imagine. They could be maybe information about houses for sale, and then you could say, oh, I like this one, I don't like that one, and then click it, and then maybe you would get some more information and more images in like at 90 degrees, sort of boom, 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 in front of you, in front of your face. Okay, so let's look at the code. Right, okie dokie. Just to minimize all them. There we go. Start from the top. Okay, so some of this code is similar to code I've showed you previously in some of my other examples, but there are some differences. So I'll go through. I'll point those out where I can. Okay, so I've got some private member variables here. I've got the scene view one here. That's pretty bog standard. We'll instantiate that when the session runs, I think. Then we've got these plane nodes dictionary here, and what's that? That's just recording the nodes. Sorry, not nodes. The 2D planes are automatically detected by the 2D surface detection. That's where I'll keep my Unsplash API access key. You'll need one if you want to do this sample. That's not my real key, that's just placeholder, and I'm missing a little angle bracket there. How lazy of me. Okay, so I've then got a list of image plane nodes, and that's just a custom object that I've created that instantiates from a regular scene node with a few more properties. And then I've got a concurrent bag of UI images. Now UI images are what you can use in SceneKit to just hold an image, and we're going to put them inside our image plane node, so as you'll see later. Then I've got my search term, which is pizza. Your search term could be whatever you want. It could be aardvark or buffalo or butterfly. Anyway, so the rest of this is kind of not the rest of it, but the next few bits are a bit boilerplate. So this is the constructor, the view controller. So this is where I'm creating the scene view and I'm adding it to the as a subview of the view. Adding enables default lighting. I'm not going to talk about that in this video, but what I'm doing is slightly different in this delegate here. You might have seen in the previous scene detection lesson, if you've not seen surface detection lesson, if you looked at xamarinarkit.com, is I create a new instance of AR scene view delegate, this, instead and then set that as the delegate down here. Now instead I'm implementing this interface here. I'm going to use the methods for detecting the planes inside this class instead. I don't think it's the right way of doing it, but that's just because I had like some variables in this class I wanted to share with those methods. It'll become clear when you later on. Okay, so that's the constructor. Then I've got a view did load. Not much going on in there. That's all boilerplate. I've not actually changed that. Then I've got view did disappear. That's again, I've not changed that. That's just boilerplatey stuff. View did appear. Now there's quite a bunch of stuff going on in here. Let's have a look. So what I'm doing here is setting up the configuration. I'm creating a configuration of AR world tracking configuration and setting some properties there. If you're doing some other sort of augmented reality experience like face tracking or face detection or body tracking, then you create a different type of configuration class here. But this is the one I need for detecting planes, so that's the one we're going to use. Autofocus enabled. Now here I'm telling it I'm only interested in detecting horizontal planes, and I could say detect both horizontal and vertical, i.e. floors and walls or tabletops, but I just want to do horizontal. And I'll also show you later on in this video how to turn that detection off when you don't need it anymore. Then light estimation enabled. Not going to go into that detail in this lesson video, and I'm not going to go into this world alignment either. It's not really relevant. Okay, so then I run this. I run the session with that configuration. Okay, then I set up these new UI gestures. So I say when the user interacts with the screen, either by panning, by moving around, or rotating like this, or pinching, go off and do these things. And I'll talk about them in a bit. All right. Then what I'm doing is in sort of a background thread, because I don't want to go off and do something that takes a while and then slow down the UI thread. I'm saying go off and get me a URL, an array of strings, which are the URLs of two images returned from the Splash API. Probably best if I just show you. Okay. You'll have seen something like this in a previous video of mine. So create a new web client. That's the URL I'm crafting to call the Unsplash API. I need to pass it the key, number of items per page. I'm saying I'm only interested in landscape. I could say square or vertical, and here's the search term. So that gets that information back, and I'm iterating through those results and adding them to a list, and then returning an array of strings, which are just URLs to images. Okay. Let's do Control minus to navigate back to where I was. Control minus, a very good keyboard shortcut. Need it again, in fact. There we go. Right. Then I'm iterating through those URLs I've returned, and I'm saying, okay, go get me the UI image base. Go off to that URL, get me the data, and create a UI image, and I'll show you what I mean. So this is the method for that. I'm instantiating the web client again, and I'm saying go get me the array of bytes for that image at that URL, and then create a UI image from that data. And I've got a nice UI image, and that's from UIKit, and those are the ones that I'm going to use to show the image in my image planes nodes. I can show you later. Okay, so then I'm saying once you've gone and got that UI image, then I want you to add it to a concurrent bag of UI images. I'm using this special thread safe collection as I ran into trouble when I was trying to do it with a regular list. So I'm using that. I'm not entirely sure why. And then I'm saying create a new image plane node in my list with which is effectively 0.15 meters wide and 0.1 meters high. So that's effectively 15 centimeters wide and 10 centimeters high. So let's go and see what that image plane node is. So these are the images I'm actually placing on the table. That's what this image plane node is. Okay, so that's I put all these classes in the same file because I put them on xamarinarkit.com, and it's easy just to read it all in one place rather than navigate around. This isn't how I would structure my code normally. Okay, so I'm passing in the width and height, and I'm creating the geometry for this image plane node, which I'm inheriting from a scene node from SceneKit, which I do a lot. These like the building blocks. These are a bit like your Lego bricks, I guess, of ARKit. That's how I like to describe them. I use them for everything. Okay, so I create the geometry, and inside there what I'm doing is I'm creating a material, and that's how I want it to look. So I'm saying make it white and make it double-sided. Yeah, colour's sort of irrelevant, I guess, because we're going to put an image on top of it. Double-sided is a little bit relevant because not for this example, but if you don't use double-sided, it will just put them on one side, and weirdly in ARK, if you've got something on this side and you've not said double-sided or explicitly set it on the other side, you can see something from this side, but then when you look at that, there's nothing there. It's odd. So I always usually by default set everything as double-sided. Okay, so then yeah, for the geometry I'm creating the plane with this width and height, and I'm setting the materials, and that's the geometry. And then that should, yeah, that sets my image plane node up nicely. Later on I will call this update image, pass it a UI image, and set that to be the contents of that node and make it look like that image, I guess. Control minus. Now the reason I'm not setting the image right away in here, even though I've got it up here, is that I was running into trouble doing that and it kept crashing, I think. So what I'm doing is instantiating both collections, collection of plane nodes, collection of images, and then later on, once I know I'm sure they're all loaded, then updating the plane nodes with the images. Again, I'm probably doing it wrong. I'm not an expert in this code. This is just the proof of concept that I've been playing around with to try and get it to work. Okay, so that's getting the images from the Unsplash API. Okay, so at that point, let's talk about the plane detection. Because as soon as that session started, the camera's looking for planes, and it calls this did add node. So when it detects one, it says it detects like an anchor, and it says is it a plane anchor, and it is if it's detected a surface, a horizontal surface at least. And what I'm saying is I want you to create a new surface plane node, which is another custom object I've created similar to the last but slightly different. Passing in the plane anchor and the color, and we want it to be white. Now the angle here is interesting. You'll have seen previous code samples I've shown you. By default, if you add a plane to a scene, it's going to be upright like this. We don't want it upright like this, we want it flat. So we're saying effectively these two lines of code are saying just rotate it 90 degrees so it's flat. And then I'm adding that new plane node to the anchor node that it's detected. Yeah, and then add that plane node we've created to a dictionary for referencing later on. Let's go have a look at this surface plane node. Right, okay, again it inherits from scene node, and inside this constructor I'm giving it a GUID because I want to reference it later. And I was looking at this code earlier. I don't think I need that variable. I'm not sure what it does. I could pull it out, but I didn't want to risk it right before going through the code. So you might not need this, but I'm creating the geometry, and yes, let's look at create geometry. That'd be good. Again, I'm getting the material. I'm creating a new material. I'm setting its color to be white that we're passing in. I'm telling it to be double-sided, and this time I'm telling the material's transparency to be effectively 30%, I guess, I think, because I want, when it's detected this surface over my dining room table, I want to still be able to see the dining room table, but I want it to be clear that it's detected a 2D plane there, so we're going to make that plane transparent. And then I'm saying create me a new plane, and I want it to be the same size. Interesting, is that right? Anyway, same size as the surface is detected. Okay, and then I'm setting the materials of that there. Okay, so let's go back a few steps. That's surface plane node. Then I'm adding that to that collection. Now, so what that's doing, it is looking for surfaces. When it finds them, and it's adding some like a white transparent top to it, and it might not just be detecting my dining room table, it will detect my dining room table, and when it gets more information about that table, it will call this did update node. So it'll be like, oh, actually it's a bit bigger than I thought, and what this does, it hits this method and it checks it's the right one, gets the identifier because that won't have changed, and then calls the update method, which I think it just says, right, I realised this 2D surface is slightly bigger than I thought it was before, or the orientation is slightly different, or the position's changed. Then update it. That's what that's doing. It's pretty bog standard, I think, 2D plane detection. Right, so okay, so we've got these 2D surfaces that's detected with a white sort of transparent top on top. Now what I'm doing is, if I can find the method in this mess of code, let's do this. Bear with me. Again, don't put all your code in like one file. It's always a bad idea. Okay, so what I'm doing is I'm saying whenever I touch the screen, and I'm effectively only doing this once to choose the surface that I want to put these other images on. I'm saying whenever I touch the screen, okay, check what I'm hitting, what I'm touching, and if it's a surface plane node, i.e. the tabletop or some other surface around, this is the surface I'm interested in. So I'm setting the touch surface plane as the selected surface. Okay, so I've touched my tabletop, this is the one I'm interested in. I'm not interested about these other ones. Then what I'm doing is I'm iterating through the other ones, and I'm saying remove them. Oh, just didn't mean to press that, excuse me. Control minus, go back. It's a lifesaver. Then I'm saying for these other ones that aren't the table node, yes, and I can tell that by the GUID, remove them from the scene. I'm not interested in them, so I don't care if you detected the floor over there or a book surface over there. Just hide them from the scene. Just keep this nice dining room table from IKEA one. Okay, so then now I'm turning off plane detection. Now I've got the plane I'm interested in. I want to turn off plane detection. In fact, I don't have to do this, but I think it's best practices because plane detection takes a lot of battery power and processing. So if you're not detecting planes, you should really turn it off. I think is what I'm read anyway. So in order to turn it off, I don't think there's an easy way other than creating a new configuration, this time with plane detection set to none, and setting that as the configuration. Okay, so now we've turned plane detection off. We've got our tabletop we're interested in. Then because you can't iterate through this concurrent bag of UI images, I'm converting it to an array. Again, not the best code. I'm sure you could do this a lot better. I say that a lot. Okay, so then I'm iterating through 10 items. I've started at -5 and 5 because I kind of want to, if the table's this big, I kind of don't want to start in the middle and go off this way. I kind of want to start off to the side and go even spaced around the center of this table if I can. That's what I'm trying to do. Again, proof of concept, not working perfectly, but it sort of shows what I was trying to do. So for 10 of these images, I'm going to iterate over. Get me the X, Y, and Z coordinates. So the X coordinate, I've tried to say try to get the middle of the table. I tried to anyway. And then because I want each image to be slightly different X coordinate than the previous one, I'm basically saying 3 centimeters, 15. Anyway, make it slightly further apart than the previous one. Then the next one we're going to put down. Trying to put that halfway in the middle of the table again. I don't think it's worked, but that's what I'm trying to do. And then the reason I've set the Z index like this is because, if you've done this code, you'll realize if you put any nodes overlapping in the same space, they kind of, you can see a bit of interference and it kind of shimmers and it doesn't know which ones to show. It's a bit rubbish. Actually, I understand why it does it. So in order to stop that, I've had to set the Z index to be so that the images aren't trying to occupy the same space, so they're slightly above each other, hopefully ever so so you can't see the difference, but they are slightly, a bit like Z-index on CSS. If you ever use Z-index, and sometimes you have to say it's slightly higher than another one, it's a bit like that. If you've not used CSS, then you're very lucky. Okay, so then digressed. I'm getting the image node from the list I created earlier. I'm setting the position to X, Y, and Z, adding it to my dining room table. I probably should just rename that variable dining room table. It'd be a lot clearer. Anyway, then I'm saying update that image, set that image to be one of the pizza images we retrieved earlier. Yeah, so that's, at this point it should have iterated through that 10 times. Yeah, and added those 10 images ever so slightly, and then that's kind of it until we start interacting with the images, that is, and that's where these gesture recognizers that we set up earlier come into play. If I could find them. No. Yes, here they are. Okay, so let's do the pan gesture first. Now, pan is just sort of scrolling your finger across the screen, up and down. So what we're doing is saying the area, getting the area that was panned from the view, getting the location of the area panned, and we're doing a hit test result, and we're basically saying, did you touch anything when you were doing this pan gesture? Now what I'm doing here, I'm saying if you were touching the dining room table object, I'm not interested. I don't want to interact with the dining room table. Return. So therefore there's only two custom objects that it could be touching. So there's the dining room table one, which is the surface plane node, and then the image node. So therefore we must be touching an image node. And then again, this is code I've just lifted. I'm saying if it's changed, then get the translation. I guess that must be the where you started the pan and where you finished it. And then do a local translate on the node to change the position of it, the X and Y position. We're changing the Z position because that kind of makes sense, because we want to be moving the image only in 2 dimensions, either up, further off away or closer to us on the table, or left or right. We're not lifting them up or down. It's very difficult to do that on a 2D screen anyway. Now these high values here, I just read that you want some like a high value here to divide by to make it smooth. Apparently if that's a low number, it's very jarring, the movement, the pan movement, so you need a high number there. So that's the pan gesture. Then the other two that are very similar. The rotate one is, I don't fully understand what all this code is doing, but it works, but I will show you anyway. And then that's just detecting the rotation. Again, we did the hit test code there, detecting the rotation and then changing the Euler angles. I'm not convinced changing the Euler angles is the right thing to do, but it's working. So yeah, I'm going to leave that alone. Then the pinch gesture here. Yeah, hit tests there, and then it's just changing the scale of the node, making it bigger, well, depending on whether your pinch is going up. It's not really pinch, is it? If you're doing that, it's not pinch. That's a pinch. That's like an unpinch. Must be a word for it. Might look that up later. Anyway, and changing the scale, and then it changes scale back to 1. I don't know why it does that, but it was in the code, so I'm going to leave it in there. Right, so that's everything. Okay, so let's have a look again at the effect. I think I've gone through the code. Let me just double check. Yes, we looked at the custom nodes. We talked about them. We did all that. Yeah, that's everything. Okay, let's look at the effect again. Right, so this effect is doing the plane detection. I touched the table, it's turned the plane detection off. Then it's recognizing the UI gestures, the pan ones when I move them around like this, and the rotate ones when I do this, and the scaling ones when I do this. Now this is a pretty boring example, but if you think about it and use your imagination, you could do an awful lot with this sort of stuff. These don't have to be images. These could be information of products these could be house prices and house information, and you could say, oh, I'm not interested about what these, swipe them away, bring these other ones in, make it bigger, and then maybe double click or long press on some of them, and it could pop up more information about the house in front of you, and just provide more information or images, just not on the table, but more, again, upright, just in front of your face like this. So you just got to use your imagination of how useful that will be, and what it's going to be like when we're using augmented reality glasses as well, and we to see the sort of stuff, which will be soon. Okay, so there you go. That's we did a bit of 2D plane detection and UI gesture recognizers, and this is the effect that we have achieved. I hope you've liked that. Follow my YouTube channels for more videos. Follow me on Twitter for more sort of experiments in augmented reality using Xamarin and ARKit and C# and .NET. That's all I've used for this. Nothing too special or fancy at all. It's you could be using this tomorrow if you wanted. You don't need a fancy headset, just an iOS device, a Mac device, so you can run and compile the code and deploy to your device. And yeah, it's pretty fun. I'm enjoying it. Anyway, till next time. See you later.